Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Aliyn. For math homework help, call in Bakersfield 636-4357. Everyone else 1-866-636-6284. Email dothemath@kern.org. We're online, dothemath.net, and on social media.
All right, nicely done. So, Aliyn, where do you go to school and what grade are you in?
I go to school at Stockdale and I'm in 5th grade.
How is 5th grade?
It's really good.
What's so good about it?
We get to do math problems and we get to challenge ourselves and we get to learn more.
Okay, so you get to learn more. So you said you get to do math problems. Did you do math problems in 4th grade?
Yes.
How were they?
They were good.
They were good? Are these ones even better?
They're good too, but they're not better, but they're the same thing.
Oh, good. So what do you think will happen when you get to 6th grade?
They're the same thing, they'll just add something more to it.
But you think they'll be better? Oh, I think they'll be better. Wait until you get to 6th grade. I bet you they're going to be better when you get into 6th grade. But anyway.
I can't wait.
No, well, good. Well, you know what? Get through 5th grade first, all right? So first thing we actually need to get through is the social media problem of the day. Are you ready for this?
Yes.
All right, let's take a look at it right now. So it says, where does n equal 7? So n has to equal 7 in one of these equations. So we have 4 different options up there. And looking at that, what are you thinking of? What do you think you have to do first in order to figure this out?
We first have to subtract the problems.
Okay.
So let's say we have 10, and we also, 10 minus 4 equals 6, and we have 3n. So n equals 2, but I don't think that will be the answer. 10 minus 4, that will be 6, and 5n. But n is going to stand for something else, so I don't think it'll be answered. Because when you have n or something, it'll be like 5 blocks or like 5, 2, so it's going to be 10. So I don't think that's the answer.
Okay.
But then when you look at C, 10 minus 3 equals n. So that's just one n. So I have a feeling that might be the answer. 2 plus n equals 8. Okay, now that we know 8 minus 2 equals 6, so that's not going to be the answer. So I'm positive the answer is going to be C.
Okay, so you worded all of it out and you spoke very eloquently about that. And I was surprised how you took the answer and worked backwards from that. And at the end you said you're positive that the answer is C. You're 100% positive that the answer is C. You have no doubt.
No doubt.
All right, there you go. I like the confidence in there. Let's take a look and see if C is indeed the correct answer for today. There you go. So n standing for 7, 7 plus 3 is 10. Nicely done. First problem out of the way, huh?
Yeah.
Not too bad.
No.
Hey, you know what? We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Starting today, as well as the next couple of weeks, we will be giving away tickets to the Kern County Fair. So if you happen to call in, we do one of your math problems, you will be going to the Kern County Fair for free, courtesy of our friends at the Kern County Fair. Time now for today's Math in the News. All right, today's Math in the News, we are fortunate enough once again to have somebody in studio with us, Merril.
Yes.
And you brought a guest along with you. The guest is Gus.
This is Gus.
The guest is Gus. So Merril, you work for the Kern County Superintendent of Schools.
Yes, I do.
And correct me if I'm mistaken, but I dare say I'm not going to be mistaken. At my school, the administrative assistants are the ones that run the school pretty much.
Well, that isn't anything that I'm doing here, but I'm grateful to be an employee at KCSOS.
So what is your role with KCSOS?
I'm the Senior Executive Administrative Assistant to the Superintendent.
There you go. So Dr. Mendaburu depends on you a lot for what he does.
Correct.
Because he's in charge of the entire county of Kern,
Very
all
big
schools
job.
and stuff like that. So you've got a lot on your plate as well.
There are days, yes.
Okay. So you've got Gus, and briefly, how long have you had Gus? And we'll get into what Gus is here for in a little bit.
So Gus just had his second birthday, so we've had Gus for about a year and a half. We got him when he was 6 months old.
Okay. Well, today is the 23rd anniversary of the remembrance of the activities on 9/11
Yes.
that occurred in New York City, Washington, D.C., and Pennsylvania. And we can see up on the board here, we have a photo of service dogs, and a lot of people are familiar with service dogs around the community. And a lot of times they were used for blind, seeing eye dogs, things like that. But there's also memorials set up for dogs that serve people in other ways also. And this one is in New Jersey, commemorating the dogs that helped out during 9/11. And we've also got some other ways that dogs help out. And here's one from 9/11. And a lot of the dogs that were used during this were actually trained in other environments, let's say, like forestry and things like that.
Yes.
So it was kind of difficult for them to work through this type of terrain, but they still did what they were brought on to do. So there's a lot of different things and a lot of different ways that these dogs help humans. And the way they get transported there, I mean, this is
Absolutely.
Right. I mean, pretty
They're
daring
remarkable what they do.
way to get them there. But then finally, we've got one here more on the emotional support. And
Yes.
that is what Gus is here for also, correct?
Gus is a therapy dog, and so yes, he provides emotional support for a variety of groups in the public.
Now, in order to become a dog like Gus is and doing what he does, they need to have a proper temperament. So
They
how
need
does
to
that
have
start, and how do you know a dog is going to be a good dog for this use?
So we purchased Gus from a breeder that breeds dogs to do this very thing. So we knew going into the purchase that he was going to be a therapy dog, and he was 6 months into his training when we purchased him, and he had the perfect temperament.
Good. So there is a therapy dog organization where they need to get certified. How long
Correct.
a process is that?
Approximately a year.
Okay. So, and Gus is two, right?
He's 2, so
All
he's
right.
been a busy guy.
So, are there times when Gus visits other places other than with you?
Yes, convalescent care, hospitals, and schools. So he has spent quite a bit of time in the school districts.
Okay, and I think we've got some footage here. And talk to us a little bit about where Gus is at this time.
So prior to my employment at Kern County Superintendent of Schools, I worked for Rosedale Union School District, and Gus spent quite a bit of time with me there, and he's being shown right now at Patriot Elementary School, where he provided emotional assistance on an incentive day to TK through second grade students.
And I think that a lot of times a dog like this going into a classroom will help students in a lot of other ways as far as emotions go, but wanting to be at school a little more also, right? Helping with attendance and things like that?
He helps with attendance. He provides assistance for incentives for students who perhaps have a behavior issue that they're trying to overcome. He is utilized as incentive for that. And he also really helps to boost confidence for students who are struggling readers or having perhaps any kind of academic struggle. Sometimes when they are in the presence of Gus, they have a little more confidence to read aloud or do something that maybe is a little more challenging for them in a classroom setting.
Good. So, I mean, it's a benefit for all.
It's a benefit for all.
And have there ever been any instances where you see Gus kind of interacting and it's kind of like, all right, well, maybe this isn't working at this time or whatever? I mean, is there always, you never have a problem?
Knock on wood, we've never had a problem with
Okay.
Gus. He really just has that special temperament.
Okay, and I would imagine that is I mean, do
It's
you have
the
any
key.
idea like how early they can figure out this dog is going to be good with the
Well,
temperament?
yeah, apparently this gal that is the breeder, and we got him in South Carolina, she knows. She can identify which dog would be good for which scenario. So knowing that this was what we wanted to do with Gus, she identified him early on and then gave us regular updates as to whether or not she thought he was going to be able to complete the training, and she was correct.
So Gus completed the training. Are there other trainings that Gus will need to carry on with or go through over the years?
Nothing other than obviously we have to maintain socialization and he has to be in good health. So we have to have regular visits at the veterinarian just to make sure that he passes everything with regard to his health.
So How often is Gus in this building?
Gus is in this building 2 to 3 times a month. He is at a school site more frequently.
Okay.
So his calendar books up very quickly.
So when Gus is in the building, and this is a 7-story building with a lot of offices on it,
Yes.
does Gus have time to visit everybody that would like to visit Gus? Or is this kind of like a sign-up thing, or does somebody just go, hey, I'm taking Gus for the day, and away he goes?
I think that there would be plenty of opportunity for Gus to get around City Center and the other buildings. I think lots of people would like to have a little Gus time. We probably need to create a schedule for him. He might need his own calendar.
So is there a possibility of having a partner with Gus at some point in the future if demand is high?
Of course, yes.
Can never have enough emotional
You
support.
can never have enough emotional support. You can never have enough Gus.
There you go. Well, Merril, we certainly appreciate you taking out some time to come visit us here on the set of Do the Math. And I mean, well-tempered dog right there. That's
Yes.
exactly what you want, right?
Thank you very much.
There's Gus. And you know what? We're going to check out some exponents right now.
Hey, good afternoon, I'm Scott, and we're gonna do a little bit of math today, as is the case usually on Do the Math. But I have a couple things you might be interested in because I know that in my classroom, my students often get this wrong, and I don't want you to do the same thing. And that happens to do with exponents. So let's say we have a couple of problems here. Let's say we have like 4 to the 3rd times 4 to the 5th power. Now some of my students will say, you know what, Mr. Hinder, I have heard that there is a trick to doing this problem. And I'll say, okay. Tell me what's going on. And they do it wrong. So here's what I tell them to do, and I'm going to suggest that you do the same thing when you are working on exponent problems. I always say to write it out. If you write it out, you get it right. Both rights in the same sentence there. Here's how it works. 4 to the 3rd, most of you know that means you're going to have 3 4s. So this is 4 times 4 times 4. There's 3 of them there. In fact, you can make a little branch here if you want to. And guess how many there are here? So we have 4 and 4 and 4 and 4 and 4, 5 of those. And then in the middle, of course, we're multiplying those together. If you want to combine these with the same base and figure out which exponent comes at the end, just add them up. 1, 2, 3, 4, 5, 6, 7, 8. If you happen to know a little bit of a shortcut about how to get to the 8, go for it. But you got to know where it comes from. Here's where the problem lies. Sometimes a student will have a problem like this. 4 to the 3rd power and that whole thing to the 5th power. And that is a whole different answer. I'm going to ask you to do something that I ask my students to do, which is take an extra 12 seconds and write it out to make it right. Here's how it works. 4 to the 3rd, you know, means 4 times 4 times 4. And all this says is do that 5 times. 4 times 4 times 4. 4, 4, 4. 4, 4, 4. Good thing I didn't do 6s, huh? 4, 4, 4. How many 4s do you have at the end? Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm not going to tell you about any kind of rule or way you can quickly do these problems. I think this is the best way because not only can you see what's going on, but it has been my experience that most students find it, they can get the right answer if they can draw it out and see everything that's actually happening. So don't forget, write it out to do it right.
Thanks to Scott for that, and write it out. And it was fun how he had a lot of 4s on there. And speaking of 4s, you're not going to get 4, but you're going to go to the fair. So if you call in to Do the Math today and next week and probably the week after that, and we do one of your math problems, you will receive a ticket to the Kern County Fair going on this year. And I do believe it starts on September 18th. If I'm not mistaken, I just had approval and confirmation that that is the start date for the fair. In studio, we have Aliyn, a 5th grade student from Stockdale Elementary. We've got Cece in studio also. And since Scott was working on the 4s, using that as a base, we're going to have Cece hit the 4 4s tab right now. And this is going to be a little something for you, Aliyn, that I don't know if you've ever seen, but tell me right now, have you ever seen a problem like this?
Yes.
You have?
Oh.
Like 4 to the power, the exponents, 4 to the power of 3.
With exponents? Good. Okay, so that's what we just saw Scott doing. But have you ever seen a problem with just 4 4s like that without anything else yet?
There's no addition, no subtraction, none of that.
Big day
yeah.
for you, sister.
Okay.
Big day, let me tell you right now. So what I want you to do is I want you to think of a number, and you can say it out loud, any number between 0 and 10.
7.
7. So grab one of the markers right there, and at the end of the last 4, I want you to put equals 7.
Oh, I know. Okay. See where we're going with
Okay,
this.
so now you are going to work through using the 4 4s. You have to use all 4 4s. And in between each of the 4s, you can put add, subtract, multiply, or divide. You can put any of those symbols you like. You can use any other symbols you like as well, grouping symbols, decimal, square root, any mathematical symbols you like. But you have to use all 4 4s to make it eventually come out to equal 7. So you will also know a little bit about order of operations as you're going through this. So when you write something down, you can erase it also, and if you want to change the color of the marker, maybe Cece, let's do red so that,
Okay, and
I think this
hit
down
the
below, you
red,
can hit the
and
red.
there we go, and that should do
All right,
it.
so Aliyn, as soon as you're ready, go ahead and let Cece know what you want to start thinking of and start putting things up there.
Yeah, so just kind of talk us through what you're doing.
So maybe we can like group them,
Okay.
and then we can subtract as also,
Okay, all right.
like 4.
Okay. All right. Okay,
So 4 minus 4 is going to give you 0.
right.
And we also have 0 here.
Okay, but we need it to equal 7. How are we going to get there? Dun, dun, dun. Right?
I thought you had it very quickly,
Ah,
because there is
okay.
a way to do that, but
Oh,
we're going to let
wait.
you get through this.
No, wait, we got to erase. And I was thinking that was what we could do, but we got to go here, I think. There we go. All right. So you want to erase this and start again? Okay. Okay, you we'll do this. Go back through.
Nice and efficient with the fist there.
There we
Cece.
go. All right. So back we go. Red is on. Oh, no, we just want red. We're good. Okay. What are you thinking next?
Okay, I have an idea.
I'm liking it. What are you thinking? What's going through your head?
So like 8 minus something to get 7.
Right, so what are we subtracting to get 7?
So we have
So 8 minus,
1.
okay, so how are we going to make a 1 with those 4s?
So
We can add, we can subtract, we can multiply, we can divide, we can do square roots, we can do all those kind of things. What can we do?
oh, you can say 4 divided by 4.
I like it.
So it equals 1.
Okay.
And 8 minus 1 equals 7.
Perfect, so let's throw a minus, yep, there you go. I like it.
There you go, nicely done. So what I'd like you to do is
Okay.
switch the pen to blue.
All right.
Now leave everything that you've got up there, and underneath what you just did, find a different way to get to 7. But you can't do 8 minus 1 again.
Okay, so we're still going to have 4 4s. Figure out, what are we doing with 4 4s to get there?
Okay, so we have 4 4s. That's what I said. 4,
Okay.
4, 4, and another 4.
Okay, still equals 7. Good. Okay, tell me what you're thinking.
So let's see. 14.
What's going through your head?
Try to think like if there's a way to multiply these two
Okay,
numbers.
okay, I like that.
So we have 16. Can I put it up here?
Yeah, sure, absolutely. That'll work.
And then we can also, maybe we can just add these 2 again.
Okay, so if we add those again, that's going to get me to 8.
Yeah.
Yeah.
It won't.
Oh, it's not going to work real well, yeah? Okay, so we want to try something different? I still think you can multiply, but what do we might want to multiply by? 2 times what is going to get us closer? Because 16, that got really big when we needed to go back down to a 7, right?
Yeah.
So 4 times,
So 4 to get to 7, maybe 4 times.
remember he told us we could do a lot of other things. We could take square roots, we could do other grouping, we could...
We can do square root.
We can, yeah. So what do you want to take the square root of?
So the square root of 4.
Okay. So if we do it, oh, I guess no, you're right. Multiplication is commutative. You can do it wherever you want. True.
So the square root of 4 is 2.
Right.
So let's say you had 2 right here. 2 times 4.
Okay, so show me, go ahead and put the square root there so we can see that. And over the 4. So we're going to do the square root.
Maybe help her put the square root in there if
okay.
it's
we're going to do that real quick.
There we go.
There we go. So we've got 2. So 2 times 4
is 8.
Okay. Oh. Well, we'll just cross that. Okay. So if you want to put an 8 there, you can.
Is
okay.
And then we can say 8. So we can say 4 divided by 4.
Okay. We could go back to that again. It's not exactly the same. It's sort of.
Go ahead and write it, and then I'll discuss with it what we're going to do.
And put your subtraction sign.
Mm-hmm.
So do you still have 8 minus 1?
Yes.
You do. So it's exactly the same. You did it a little differently, but it's a good way to do it. I want you to find another way where you're not doing 8 minus 1.
Oh, okay.
And if you leave everything up there the way it is, you only have to change one thing, and you'll still get 7. You only have to change one operation, and you will still get 7, but it'll be a completely different way than 8 minus 1. You only have to change one operation.
I hate it when he thinks like we're supposed to read his mind, right? One operation. So do you think maybe we change the multiplication?
Yeah.
Maybe
that would be a good start.
We could. Okay, so if we change the multiplication, it doesn't do it. That's the old board. We got a new board. We're still learning. Hey, how come it worked for you? You're magic. Okay, so what are we doing there instead?
We could try to.
Okay, I got it. Go ahead, continue. All of a sudden.
It comes just like that.
Just like that. So we've got a 2 and we got a 4.
We got a 2, we got a 4.
Instead of
So you know the other part, 4 divided by 4 is still going to be 1. So if you have 1 and you need to get to 7, but we're not going to subtract, what do we need in the other part?
So we have 1 and we're doing 7, but we're not going to subtract.
Right, so we're not going to subtract this, so we're not going to get this.
Yeah.
What are we going to get here? And maybe not subtract 1 to get 7, but instead something else 1 to get 7.
So just think of the opposite of subtraction.
Is?
Addition.
Right, so if we add here, what number do we need to have here?
So if we have like turn this into addition sign.
Yep, so we change that to addition, so what number needs to be here? Plus 1 gives me 7.
Awesome. Don't give me negatives right now. Hold on.
You got this.
Because no one gives me 7.
What plus 1 gives me 7? 6,
So,
right?
6.
Yeah. So how are we going to get 6 out of 2 and 4?
Wow. So we can get like 2 and 4.
2 and 4 gives us 6 by what operation?
2 and 4 gives us 6. So if we say...
We're going to add, subtract, multiply, divide 2 and 4 in order to get 6.
2 and 4 in order to get 6.
We're going to add, right? 2 plus 4 is going to give me 6. So we're going to put an addition sign here.
So that way you were able to keep everything, but you just took away that multiplication, made it addition. So now you've got 6 plus 1 is 7, and for some great work, and we made you struggle a little bit right there, right?
That's right.
Excellent. You've got yourself a ticket to go to COM, so hopefully you have a little bit of fun out there. They've got an ice cream zoofari coming up this weekend, and we'll be back with more right after this.
Will an asteroid ever hit Earth?
Do aliens exist?
Is there water on Mars?
Where did our moon come
from? Are there rainbows on Mars?
Is NASA aware of
Mars ever look like
Could
microbes
Is
Mars habitable?
That's a really interesting question.
Well, yes.
Yes, of course.
Yes.
Actually, well, maybe.
No.
No. It is possible.
Yes.
Yes.
The answer is yes.
In fact, we're quite confident.
It is proven.
There have been several theories.
One that we have been trying to understand.
The question of, are we alone?
The universe is a pretty big place. We've only begun to look.
We haven't really observed it.
We see evidence.
Where do we find those worlds?
That's why it's so fascinating.
So stay tuned.
To keep the long story short,
we have been trying to answer that question definitively.
And explore and figure out
the quest for that answer.
And as of yet, the answer is still definitely maybe. So keep your eyes peeled and keep looking up.
Is there life on Mars? So we've been looking for life on Mars for a long time. And while NASA hasn't found any evidence of life now, we found lots of evidence that Mars could have supported life in the past. There's lots of pieces of evidence that say there was once a huge ocean on Mars and an atmosphere that could have supported life. But there's still a lot of Mars left to explore. There are places that are potentially habitable, like the deep subsurface. There are places underground that could have fluids in them where organisms could live, and they'd be protected from the radiation that's so harmful on the surface. We're just now getting instruments onto the Martian surface that can help us understand these potentially habitable places, and we can ask deeper questions about the potential for habitability in those rock cores. So is there life on Mars? Not that we've found yet, but there's still a lot of Mars left to explore.
A lot of Mars to explore indeed, and I know there's a lot of students out there just thrilled with studying space and everything about Mars because that is a hot topic with NASA right now. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. We are celebrating our 23rd season of Do the Math this year. We love our brand new set, so if you have not had an opportunity to see all of it yet, you will during the course of the season. Right now we're going to go to an extended part of the set, which is outdoors of the Do the Math studios. And we've got Sam downstairs, and Sam has a special guest, Ernest and Enzo. So Sam, tell us a little bit about what's going on with Ernest and Enzo downstairs.
So hi, so today we have Officer Earnest. Thank you so much for being here. And we have Enzo. And so tell us, she's from the Kern High School District. And tell us a little bit about what you guys do.
So Enzo is what we call a gun dog. He's a lab. He's 2.5 years old. And he was trained to find guns. So he will find or smells the gunpowder from the gun for the ammo.
Nice. So you first started as a deputy, right?
Correct.
Yes. And then how did you get in with the high school district?
So I was a deputy for the Kern County Sheriff's Office. I retired from them around approximately 7 years ago. And then I decided, I want to work more with kids. So I decided to apply and go to the Kern High School Police Department, which I did for the last almost 7 years, and I have enjoyed the position I've had. And then around 3 years ago, we decided to search about having a K-9 program in our department because we have never had a K-9 in our department. So we decided to do a search, and then I applied for the position, and I got the position.
Nice. So what does it take to train a K-9?
So great question. So usually when we buy a K-9, he's already trained, and they usually have over 100 hours of training for that target order or for whatever they are trained for. And then from there, we buy him, and the trainer comes to our department and train me for 2 weeks, and he would train me in how to really see the change of behavior and to know when Enzo or any K-9 finds the target order that he has been trained to look for.
Right. And so you were telling me earlier that you're with Enzo 24/7, right?
Yes. So Enzo is like having a little toddler. He's with me every minute of the day. And holidays, every day he's with me.
That's so great. And you said he's 2? You said?
He's 2.5 years old.
Yes, all right, that's so great. And so you said you're with the Kern High School District, and so what are some other jobs that Enzo does?
So besides Enzo being so great in doing his job, which is locating a gun, ammo, He's a very special dog. He loves people. He loves to be around people. I have taken him to special ed classes, and the kids just love him. I have gone to offices where I have heard staff members, I'm so glad that you brought Enzo because I am not having a good day and I just needed a hug from Enzo. And, you know, I'll give them some time there, they play, and they really feel that relief of, I'm okay now because Enzo is here. So Enzo loves people and he really makes the whole environment just calm down.
Oh, sweet dog. What do you think Enzo's favorite job or part of his job is?
I think his favorite part of his job is when he's searching, he gets very excited because he knows that when he finds the target odor, it is time to play. It is time for mom to throw the ball and we're gonna play. I think that's his favorite. And you will see he gets this smile in his face like, yes, I did my job, now ping me.
That's so great. So how long do normally the canines work for? Like how many years?
So they work between 5 to 7 years because you figure Enzo's 2.5. By the time we usually get a canine is around 2 years old, and then they usually work 5. That makes them 7 years. So usually a dog will work between 7 to 9 years. So between 5 to 7 being that by the time the canine handler receives the dog, he's already 2.
Right.
So you add between 5 to 7 years after that.
Okay.
Yes.
And would he stay with you after that?
So good question. So if God willing and if we both retire at the same time, yes. What happens with the department is I actually buy him for $1.
Aww.
And then I'm able to take him home and all the responsibility falls on me.
Yes. Well, that's great. Okay, so I know you guys have done some searches in high school, so we have set up a search here for Enzo. And so right now we have out there hidden, right? Some ammo. And so we're gonna let Enzo do his job and we're gonna watch him in action.
Yes, we're gonna start searching. It is a little bit windy and that takes a lot of effect on the smell because just like anything, if we have like a hamburger there and you're coming out of the building, you're gonna smell it right away. We know because we're able to see that it's not here and we're able to locate and say, hey, there's the hamburger I was smelling. Dogs cannot really see that, oh, that's a gun, because they're not looking for a gun. They're not looking for ammo. They're just looking for the smell. See, so it's almost like us coming out and we cover your eyes and we tell you, go follow the smell. Tell me where the hamburger is. So that's the way you're going to see. There's a little bit of wind, so we'll see how Enzo does. Okay, Enzo? All right. Sit. Ready? Search. This one. Good search. Good search. Good search. This one. Hey. Search. Search. Sometimes he might be smelling other dogs and he gets attracted to that. Then he won't have the change of behavior or the final alert. Search. Search. So right now you can see him, he's putting his head up because he's following the smell. Obviously I know where it is, but because of the wind, he's following the smell. Search. And he's going to the restroom. Good boy, good boy, good boy, good boy. Part of it of the distraction there probably because he needed to go to the restroom. But if you're able to tell that, okay, he got his nose in there and he was smelling, and then he sat down.
I love that. Good job, Enzo.
So then after that, we just kind of mess around with the ball. He loves to go after it and pull it and stuff like that. So,
All right. So if anybody would like more info, where would they find this about? If they want to be a canine handler or just
Sure. Being a canine handler, you have to be a police officer first, and after you become a police officer, after 2 years, you could apply for special jobs, which is canine or traffic controller and stuff like that. So after a couple years of being a police officer, you could apply. The sheriffs have canines, BPD have canines. With our department, it's a little bit different. With our department, you have to be a police officer in another department for at least 2 years, and then and then you could apply to become a police officer with us.
Right.
And then after a couple years, you could apply to be a canine handler.
That's great.
Yes.
Well, thank you so much for being with us.
Thank you for having me.
Thank
Yes.
you. So if there's anything you would like to see, you can find all of this information on Do the Math social media. Back to you, Mike.
All right, thanks for that, Sam. Be sure to thank Officer Earnest and Enzo for coming down today. Yet another service dog. We're learning a lot about the dogs today and how they service everybody right now as far as emotional support, looking for ammo with the Kern High School District. We do have phone tutors available Tuesdays and Wednesdays throughout most of the school year. In studio, we have Aliyn, a 5th grade student, going to be working on some triangles right now and adding some numbers. So here's the problem that you guys are going to be working on. So it says, you have to have each of the triangles so that when all the vertices of the triangle are touching, it adds up to 13. The 5 and the 9, or the 5 and the 3, cannot be moved. So you're going to use 1, 2, 4, 6, 7, 8, 9. Okay? So you can write the numbers in there, but each triangle has to add up to 13.
Okay.
Go to it.
Okay. Tell me what you're going to think about or how you're going to do it as you go. What color do you want first thing?
I'll just take the yellow one.
You want to do blue? I don't know. Does that yellow show up very well? We might want to do maybe like a blue.
Try it and let's see.
Okay.
Try a number. Just throw a number in there.
Oh,
we're not going to use
yellow.
yellow.
We're not going to use that. Okay, let's try blue. Oh, I am on highlighter. Well, that would explain why that didn't show up so great, but we'll go ahead and use blue anyway.
So 5. I'll break it down.
Okay.
To 1 and 4.
Okay, now remember, he said that the vertices of each triangle have to make a sum of 13. So we've got this triangle here that has to add up to 13.
Oh.
Yeah, so we're starting with that 5. So really, these
10.
two need to add up to what?
Those have to add up to 5. So all of this is going to add up to 10.
No, so we need it to add up to 13 though. Okay, so let's go ahead and you've got the magic touch on the erasing, so I'll let you. Okay, so what do you want to try next?
So I can try 7.
Okay. And 7 and 1, okay, all right, so that's good. So 7 plus 1 plus 5, that gives us 13 and we're good, yeah?
Yeah.
Okay, so the next triangle, we're starting with the 1 here, so we know that that has to add to
13.
Right, but we've already got the 1, so what do those 2 spots need to add up to?
They need to add up to 12.
Okay, how are we going to do that?
So you can put.
What numbers do we have left?
So we used one. We used the 1 and the 7.
Yeah. So what might
we have
left?
2.
Okay.
4.
Yeah.
5.
Okay. Oh no, we don't have 5. 5's already there.
Oh, so we have 2, 4, 6, 8, and 9.
Okay, perfect. Okay, so what are you thinking?
So we could put the 9 up here.
Could.
So that gives us 10.
Okay.
So that means we're going to use our 2. Wait, no.
Oh.
We're going to use our.
Uh-oh.
We don't have a 3.
Yeah.
Not called.
Okay. So what do you want to try next? So can't use the 9. What do you want to try next?
So we can't use the 9. Have we used our 8?
We haven't used our 8, so we could go ahead and try the 8, sure. Okay.
So the 3's already used.
The 3's already used, but we've got 8 plus 1 gives me 9, and it needs to add to 13. So
4.
There we go. Okay. So far I'm liking it. We'll see if we can keep going.
This group has
That's 13. Okay, so we have 4. So now we've got to add up to what?
Now we got to add 13, so we need 9 more left.
We need 9, okay.
So we have our 3. So we used our 3, we used our 4, we used our 8, we used our 1, we used our 7 and 5. Then
So we've got a 2.
2.
We've got a 6. And we've got a 9.
So we got 2, 6, and 9.
That seems like we might be a little stuck. Yeah.
So I'm going to help you out a little bit here because there's a lot of different ways this can go.
So
leave the 4 where it is. Erase the 1 and erase the 7. Move the 8 to the left 1 spot.
Right here?
Move the 8 over or to the left.
Oh, sorry, left. The other left.
There you go.
Sorry, I'm facing this way. We got you.
And erase the 8 that you already had up there. Go from there.
Okay.
8 plus 4 is 12, so we have 1 up here.
Perfect.
Go with 13.
Okay, good. So what do we know now next, for sure?
So we have 3 plus 1 equals 4. So that means we're going to put a 9 up there.
Yeah, I like it. Okay, so we have a 7, we have a 6, we have a 2. All right.
So think about keeping that top row in order. You go 9, 8.
Because you do kind of start to see this pattern of like the larger numbers work really well up here because you can kind of play around with the lower ones down here, right?
So what would come next after the 7 on top?
Right,
or after the 8?
Yeah, there you
come
go.
After the 7.
There you go.
So 7's going to go next on top.
So then we're going to have 2 here.
Okay.
So 2 plus 5 equals 7. So 6.
There you go. So there is always this opportunity to kind of start playing with it first, and then you can see how strategy starts to come into play, right? So it's always nice to have that little bit of playtime and then figure out a strategy and then move on that.
There you go. Nicely done, but you did finish all of that in time right there, and just 1 clue, 2 clues, that's it. But otherwise, that could take a long time because there's a lot of different ways you can get those vertices to add up to 13.
Right.
And you know what? Earlier we were visiting with Enzo and Officer Earnest, and there was a little bit of wind downstairs. Right now we're going to talk about some other types of winds. There you go, damaging winds and more about wind. Not quite as windy downstairs when we had Enzo and Officer Earnest down there. But we have Aliyn in studio with us. How you feeling today?
Very good.
Good, that's exactly what I like to hear. You feeling pretty good after that last problem?
Yes.
Your brain going?
Yes.
All right. So you're in 5th grade and you're working with decimals right now, correct?
Yes.
Before we get to your decimals, I'd like you to write up on the board 3 over 10, 3/10, 3 over 10. And how would you write that as a decimal?
0 and...
Now explain to Cece how you know that and how you know it's correct.
3 out of 10, that's the fraction, right?
Correct.
So if you have like something like 0.1, that's the same thing as 1/10.
Okay.
And that's also the thing as 1 out of 10. So let's say you have 3 out of 10. That's going to be 3 times because that's just saying 1 out of 10 for 3 times.
Absolutely.
Yeah.
I love that. So basically we're kind of adding, right?
Yeah.
I like it.
All right,
Okay.
and you said that you have some homework that you're doing with decimals.
Yes.
So go ahead and work out one of your problems with Cece and explain to Cece what you're doing with your homework.
Okay, so you can come on over here and put up a good problem for us. Ooh, okay, so 42 times 9.26, or 9 and 26/100ths. Okay, good. All right, so what are we going to do?
So what I learned in class, we're going to use the area method.
Okay.
Like this.
I'm going to be completely honest. I'm not sure I've learned this method before, so I'm excited to see it.
42, we separate to 40.
Okay.
And 2.
I like it.
And 9 and 26/100ths.
Okay.
So we first put the 9 hole here.
Okay.
And if you separate the 2600s into 2000s, like 2 tenths.
Okay.
And 600s.
Okay.
So it's like 0.2.
Okay.
And 0.06.
So really you're doing a lot with like place value there too. I like that. Okay, awesome. Show me the way.
So you get these two numbers, say 9 times 40. Or you can say 40 times 9.
Okay.
And then what's 9 times 40? Well, let's first say, what's 9 times 4? 36.
Good.
And because this is a 10, you add the 0 at the end.
Fabulous. I love it.
And then we say 2/10 times 40. Okay, that's going to be a little tricky. So how I do it, I say 40 out of 1 times 2 out of 10.
Okay.
Now you can only switch the denominators, so you can really say 40 out of 10 times 2 out of 1. Now we can divide them. 4 divided by 10 equals 4.
Okay.
2 divided by 1 equals 2, so 4 times 2 equals 8.
Nice.
Same thing for this problem. Hold on.
Okay. Yeah, gotta make some room.
So let's say 40 out of 1 times 6 out of 100.
Okay.
Now,
so are you changing your denominators again, or can you leave it that way?
You can leave it that way.
Okay, you can do your division or simplification starting from there.
Yeah.
Okay.
So we can say 40 times 6 equals 240. 1 times 100 equals 100. Now we're not going to leave it like that. We have to turn it into a decimal.
Okay.
Because there's 200s and 240, we're going to say 200 divided by 100 equals 2.
Okay.
And then there's also going to be a decimal point because 40 out of 100 is 0.4 because 40 out of 100 is equals.
Right, so we could have simplified and taken those zeros, right? We could have divided both the top and bottom by 10 and gotten the 24 over 10. So we've got 24 tenths.
So 2.4.
Okay.
Or you could say 2.4 out of 6, just to simplify it.
Okay.
We're going to add them later.
All right, that sounds good.
9 times 2 is going to give us 18.
Nice.
Then we say 0.2 times 2. Same process. 2 out of 1 times 2 out of 10.
Okay.
Now we can actually make this a smaller fraction.
Oh, okay, show me.
So we have 2 out of 1, which is 2, times 1 out of 5.
Okay, what happened there? So you just did the simplification of this fraction to come down to here, right?
Yeah, but sometimes you might not want to make, because this actually equals to 0.4. But if you think about it this way, 4 out of 10.
Yeah, that kind of helps us to see that better, yeah. Okay, good.
So it's 0.4.
So there are some times that simplification doesn't make it quite so simple yet.
Yeah, not yet. So we have 2 out of 1 times 600.
Okay.
12 out of 100.
Okay. So 12 100ths. So how do we write that?
We write that as 0.12.
Nicely done. Okay, and now that we've got a big old mess, it looks like you're probably going to erase it again, aren't you? Okay.
We have enough room now.
Okay.
Now we all add them. No, we're not. What we're going to do is we're not just going to add it like the regular way. You have to make sure the decimals align.
Absolutely, good.
So let's first start with the biggest number, 360. And then we're going to start with the second biggest. We're going to be at 18.
Okay.
8.
Lovely.
2.4. So that's going to be at the 2 is a ones place number.
Good.
So 2.4.
Good.
0. And then we have 0.40.
Okay.
So we have to make sure it aligns.
Now, do you have to put it in descending order, or could you just put them up in whatever order you wanted, as long as your decimals lined up?
You can put it whatever you want. Just I have to make sure decimals line up, or else it's going to give you a different number.
Right, yeah, make sure those decimals line up. But you're right, addition is commutative, so we're good. We could put it in any order, but I like this. Keep going.
The last one is 0.12. The reason why I put it to the side, because the numbers right here are ones, and we have to make sure it aligns with the ones place.
Okay.
In order to see that better, you can say 360.0 because there's actually decimals in it.
Sure. Okay, let's finish it up. What do we got?
So what we got here is, you have 2, add this together, 9.
Fabulous.
Point. Okay, so we have 8 and 8, 16, plus 2, 18.
Good.
Carry the 1, 1 plus 6 plus 1 equals 8. Then we just carry the 3 down. So our answer is 388 and 92 hundredths.
Nicely done. I think we're good.
There you go. Perfectly done, and a great way to do it right there. I love the way you explained everything. And right now we're going to check out another one of the schools in the CSU system.
From the redwoods of Humboldt to the beaches of San Diego, the California State University drives the heartbeat of the Golden State, intellectually, culturally, and economically.
As the nation's most preeminent public university system, we are 23 world-changing universities, 4,000 career-defining majors, and one mission above all, for all, unleashing potential.
It's what makes the CSU the educational powerhouse for America's new majority and the leading model for inclusive excellence. We are the launchpad for first-generation dreamers and ambitious achievers.
Where more Californians from every walk of life receive one of the most exceptional educations in the land for one of the most affordable tuitions in the country.
Every year, nearly 450,000 students call the CSU home.
But the experience is more than classes and books. The California State University is a world of eye-opening discoveries, spontaneous adventures, and lifelong connections.
Where passion meets purpose. Where students propel the world forward and themselves upward. Where tomorrow isn't just planned, it's promised for nearly 130,000 CSU graduates every year.
The innovators and caretakers who shape the future. Leaders and barrier breakers who grow our legacy.
The new torchbearers who join the ranks of our alumni.
More than 4 million strong who enrich our society, strengthen our democracy, and shine as beacons of pride and prosperity.
For their families, their communities, California, the nation, and the world.
All right, and now Aliyne's going to do a little something that she'll be doing for years to come, scientific notation, working with exponents and decimals, and very large and very small numbers. So girls, take it away.
All right, what do you want to do? Do we need to write this out? Do we need to expand them, or can we just with multiplication go to it?
Maybe we have to expand them a little bit.
I don't think we do, not for multiplication, because remember, multiplication is commutative. So let's not forget that. That means we can reorder this. So we have 1.2 times 4 times 10 to the 5th times 10 to the 2nd. So you just showed us a neat way to do that, but let's do it really quickly. And what is 1.2 times 4?
1.2 times 4, so let's first say 12 times 4 equals 48.
Good.
Then we add the decimal point, so it's going to be 4.8.
Okay, so we got 4.8 times 10 to the 5th times 10 to the 2nd. Do you know what we do with our exponents when we're multiplying?
If they're both 10, so it's going to be 10 to the power of 7.
Ah, okay, so our answer is going to be?
So it'll be like 4.8 times 10 to the power of 7.
And the power of 7, when we have that, does that make the number really big or really small?
Really big.
Really big. I like it. Did we do it in time? We
Yeah,
got
you did.
Mike?
As a matter of fact, you want to do one more?
Oh my goodness, we went that fast? Well, no. See, I just can't.
Aliyn's got it.
I know.
Let
She's
Aliyn
ma-
take care of that.
She's
thing.
magic.
She's all set.
She's pretty great at that. Okay, so I'm going to give you one more. Ready? Yeah. Ready? We're going to do 4.5 times 10 to the 8th divided by, let's do 5 times 10 to the 3rd.
So
actually, I think that, well, yeah, okay, we'll talk about it. Go ahead. So you want to divide? Let's divide by 3. We're going to do by 3 times 10 to the 3rd. Or we're going to do that one instead. Okay, tell me what we're doing here.
So we're first going to say 4.5 times 10 to the power 8.
Okay.
So I'm going to write this as a fraction. It's going to be 45.
Okay, so again, we're looking at division, so we don't actually have to do this, and especially because Mike's going to get mad at us if we take too much time. So we're going to do division. So we're going to do 4.5
divided by
divided by
3.
Divided by 3. What do we get?
1.5.
Okay, so if that's the case, what do we do with our exponents when we divide?
Do we subtract them?
We do subtract them. All right, so our answer is going to be?
So 1.5 times 10 to the power of 5.
Nice. And we learned about that in one of the breaks earlier, how to do
Right.
that. So there we are.
Nicely done. Excellent work today. Come on over here, girls. And since you are a pro at Do the Math now, you know you are going to be an ambassador for Do the Math. Do you know what that means? That means you have to let other people know about Do the Math. Oh. You can do that?
Yeah.
So when you have your shirt on, that's like your official uniform for Do the Math. Does that make sense to you?
And a badge of honor, I think.
Right. I mean, because not everybody has one of those.
That's right.
And do you know how to use a Rubik's Cube, how to solve these?
So usually we mix them up first.
Right, but what we're going to do is we're going to show this side to the camera right there because this is an exclusive Do the Math Rubik's Cube. Have you ever seen one of those before?
Yes.
Because you saw one last week, didn't you? Yeah. Well, this is the first time I've seen one actually, was this week on the show. But yeah, you mix it up and stuff like that, and then you can work on it, right? And maybe you can have some friends try it out and stuff like that and see which of you guys can kind of do it a little quicker or whatever, right? Mix it up on each other.
Yeah.
Sound good?
Yeah.
Well, you know what? I talked a little bit about the Zufari coming up at COM later on this weekend. That is the Zufari going on, an ice cream special, also going on this weekend at California Aeronautical University, because we have had an opportunity to go out there many times and learn a lot about aviation. And they are having their open house this weekend. And you can have a tour of the campus, check out the aircraft. If you have the slightest interest at all about flight, getting into a career, they've got everything that you could possibly have going on this weekend. And you can see the schedule right here. So starting at about 9 o'clock in the morning, they're going to have tours, questions and answers, admissions process. They have housing available, scholarships available, but that is coming up this Saturday, September 14th at California Aeronautical University, which is out by Meadows Field, and that is just a fabulous place, and we're very happy to have partnered with those guys over the years and learned a lot about aviation, as well as the Bakersfield Flying Club. North High School has a program going on, and all of that fun stuff. Did you learn a little bit today?
Yes.
Did you have fun today?
Yeah.
Excellent. That's what I want to hear. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.